Hello everyone, welcome to Mathematics with Shahab Yaqub. Circular measure, a chapter in pure math. Let's start with the basics. Now first of all, let me draw a circle and then let me grab some straight line segments. From the center, if I draw a line all the way till the circumference, that is the radius. And let me introduce some other terminology also at the same time. If I join 2 points on the circle by a straight line segment, it's a chord. So this is AB. So AB is a chord. This one is the center. This is the radius. And what else is there? If I join a point from one end of the circle all the way to the other end and it's passing through the center, this particular chord, this is called the diameter. We are aware that diameter is 2 times the radius because radius plus radius is the diameter. One other thing, that is if this is A, this is B, and this part of the circumference, this is called the arc length. And we use the symbol S to denote this. Radius, we use the symbol R. Now, let's draw another diagram. So let me grab a circle once again. A circle is drawn. And now I need some line segments. This is not an exact diagram, keep that in mind. So from the center till the circumference, I have drawn 2 radii. This is R, this is R. Radius is singular, a little bit of English. And radii, that is plural. So the center, the radius collectively known as radii. This is point A. This is point B. Let me take a line segment again and let me join A and B. So now this purple line AB, this is the chord. And this green line segment like this, which is arc length, which is part of the circumference, this is arc length. Let me mark an angle over here by the symbol theta. And what do I have? I have a sector that is part of a circle. So I have the sector OAB. Let me highlight it for you. So this is O till A till B along the arc length, along the circumference, and B back to A. So this face right over here, let me illustrate it a bit more. So I need a line segment again, and like this, and another line segment like this, and then using this green color over here. This shape, this is a sector, and the name of the sector is OAB. Now this purple line over here connecting A and B, that is the chord. And this region over here, which I am shading, and this is a segment. And this over here, OAB, that is a triangle. So basically, what we have broken this down into is a sector over here is basically made up of a triangle and a segment. That means if I have a formula for area of sector, if I have a formula for area of triangle, I can do some subtraction and I can find the area of the segment. So now let's go to the basics of O-level math or IGCSE. So it's either O-level math 4024 or IGCSE math 0580 or any other similar syllabi. What we have studied is that arc length AB is theta over 360 degrees into 2 pi r. and we have studied area of sector. That is equals to theta over 360 degrees into pi r square. Now in both these formulas, the angle theta is in degrees, and the ratio of theta to 360 multiplying with circumference gives you the arc length. So this over here, that is the circumference of the circle, and theta over 360 multiplying with area of circle, that gives us area of the sector. Pretty basic. Now what if I'm interested in creating a formula in which we are not using degrees, but we are using radians? So let's create such a formula. We know that pi radians is 180 degrees. We know that 2 pi radians is 360 degrees. So let's go ahead and change the formulas. So we have the formula arc length is equals to theta over 360 degrees into 2 pi r. We know that 360 degrees and 2 pi is the same. Slash it off. Remove the degree sign. Therefore, arc length AB is equals to r theta. That is a formula that you have created, and this formula is for the arc length, but what's the catch? The catch is theta is in radians. Now remember that when we'll be using calculator for this chapter of circular measure, we will be dealing with angle in radians. Therefore, the calculator should be in RAD mode. It is a must. Now, this is the first formula that we have created. Let's move to the second one. Area of sector, that is theta over 360 degrees into pi r square. Let me break up 360 degrees into 2 times 180 degrees into pi r square. Now we know that pi and 180 degrees are the same. Slash it off. Slash off the degree symbol. We are left with the 2 at the bottom, r square and theta. So therefore area of sector comes out to be half r square theta. So let's put another box around it, and again we have to make sure that theta is in radians and calculator in radian mode if you're using the calculator. But it's not just about plugging in the value of theta, it's about trigonometry. Remember, if the calculator is in the degree mode and I'm using 30 degrees, we know that sine of 30 degrees is half. If I'm using calculator in the RAD mode, instead of 30, what should I write? Pi by 6 radians. And then when I plug in pi by 6 in the sine function, or for that matter, cosine or tangent, so sine of pi by 6 will come out to be correctly half, provided the mode is in radians, angle is in radian. The mode is in degrees, angle in degrees. But since we are studying P1 and further on P3 of AS level and A level math, so we should be using the degree. Instead of the degree, we'll be using radians and the calculator in radian mode. So now let's try out a simple question. So first of all, let me grab a circle. So there is a circle over here, and let me draw 2 lines. So I need some straight line segments, something like this, and another one like this. And let me draw a green line connecting these two. Let me shade some area, that is this over here. This is O, this is A, this is B, this is pi by 3. Maybe the examiner would have given you 60 degrees. Slash it off. Write pi by 3 instead, the equivalent of 60 degrees in radians. And let me write 10 centimeter over here. Let me write 10 centimeter over here. Now, what can I do with this diagram? First of all, I can find the length of the chord AB. I can find arc length AB. First of all, if I talk about this thing, that is the chord. So let me draw this diagram. It goes like this, it goes like this, and there is this green line. Let me draw this green line like this. Now, some basic math, that is, this is 10 centimeters, this is 10 centimeters, this is pi by 3 radians. It's an isosceles triangle. So if this angle is pi by 3, and let me call this angle as beta, and this angle is beta, because of isosceles triangle, these two angles are the same. So beta plus pi by 3 is equals to pi, adds up to 180 degrees. Now we will be using pi radians instead. So therefore 2 beta equals to pi minus pi by 3, which is 2 pi by 3. Therefore beta also simplifies to pi by 3. That means if this is pi by 3, this is pi by 3, this is pi by 3, isn't this an equilateral triangle? Yes, I have proven that this isosceles with a 60-degree angle actually becomes an equilateral triangle. Therefore, the length of the chord AB is also 10 centimeter. Now, this is very sharp thinking. Not everyone will be doing this. Some people would be using these two lengths, this angle, and using cosine rule. Some people will divide into two equal halves. The angle would be divided equally, 30 degrees or pi by 6, and then they will use basic trigonometry. But I prefer to use this one or maybe the cosine rule. Similarly, arc length AB, that is equals to r theta, provided theta is in radians, that is 10 into pi by 3. I leave the answer in the exact form because that is mostly what the examiner is requiring. Now, if I draw this line over here like this, and I have this arc length which is like this, and this is the shaded region, and this is A, this is B, this is 10, this is 10 root 3. What's the next question that can be asked? That is the perimeter of the shaded region, which is 10 plus 10 root 3, put a bracket, write centimeters, the unit on the outside. Now again, have a look at the diagram, and let me just select this whole diagram, and I can copy it, and let me move over here. The next thing that I can do is that I can play around and apply the concept of areas. So let's say I can find area of triangle OAB. I think I missed out the A. So this is OAB. That is half AB sine C. That is equals to half into 10 into 10 into sine of pi by 3. This comes out to be 50. 100 divided by 2 is 50. Sine of pi by 3 is root 3 over 2. Over here, let me emphasize it again. The calculator should be in the radian mode, because if the angle is in radians, when you calculate the trig ratio, they will come out exact, provided the calculator is in the radian mode. And of course, you can also remember these values with a lot of practice. So this comes out to be 25 root 3 centimeters square. That's the area of this triangle. What else can I calculate? What if I want to calculate the area of this whole sector and then eventually the area of the shaded region? So therefore, area of sector, that is a simple formula, that is equals to half r square theta. That is half into 10 into 10 into theta, which is pi by 3. So this is 50 pi by 3, not a root. This is 50 pi by 3 centimeters square. Therefore, eventually, the area of shaded region, that equals to which is bigger, which is smaller. You have to look. The sector is bigger. It includes this triangle. So area of sector minus triangle. So therefore, I'll write 50 pi by 3. That is the area of the sector minus 25 root 3. that is the area of the triangle. Leave the answer in this form, that is the area of the shaded region, and this is known as the exact form. Now the P1 examiner, the P3 examiner, it's the exam requirement according to which the examiner will be checking. So mostly they ask the answer in the exact form, so develop a habit of doing so. What have we learned in this video? In this video, we have learned that the new formula for area of sector is half r square theta. The new formula for arc length denoted by the symbol is r theta. But for these formulas to work, what is necessary? Theta is in radians. Naturally, you'll be using the exact forms which you have already seen in the previous video. Naturally, you would be using basic trigonometry, which is either sine or cos or tan, or maybe sine rule or cosine rule, or the area of a triangle, which is half AB sine C. So getting this all together, that will earn you success in your upcoming exams. Till the very next class, take care.